40. Predict which acid in each of the following pairs is the stronger and explain your reasoning for each. And then we have letter D. So in this case, we have to figure out whether NH3 or H2S is more acidic. So in order to do this, we just have to classify what's going on here. Are these acids binary acids? Are there oxo acids? Can we use those trends? Well, it turns out that for each one of these, right, I see two elements. I definitely see a hydrogen, and then, in this case, a nitrogen. And then in H2S, I see the hydrogen, and I just see one other element, that's a sulfur. Whenever you have a hydrogen coming together with some random element, right? So this X could be the nitrogen, it could be the sulfur, but the idea is that you just have to have two different elements, and one definitely has to be a hydrogen. These are binary acids. So we're in the binary acid realm here. So we can now use binary acid trend acidity to answer the question. And you don't look at the hydrogen because those are the same for both of them. You would look for the other element. So in this case, I'm going to find out where nitrogen is on the periodic table and where sulfur is. Here on my binary acid, trend here, let's see. If I place nitrogen, actually, let me just maybe move this a little down. So if I have nitrogen up here, let's say, sulfur would be diagonally across. So as I go across a period, I increase in acidity, and as I go down, I also increase. So since sulfur is a little bit to the right and it's going down, increase and increase, it would make sense that H2S is the stronger acid. But now we just have to explain the reasoning. So what's the chemistry behind this? Well, this turns out to being linked to atomic radius. As you go down a group, your atomic radius will start to increase, right? So let's just say that we had, we have a smaller dot, right? And maybe I'll do this in blue, right? We have a small dot, and then we get bigger and bigger and bigger. You get the trend, right? So in terms of nitrogen and sulfur, since we're going down a group, sulfur would have a bigger radius than nitrogen. So if I had to draw these two, sulfur would be a little bit bigger, right? So let's just say that this is, H2S. And then if we had to do NH3, let's just maybe do the green for the nitrogen. Nitrogen would have to be a little bit smaller. And then a hydrogen is a hydrogen. Hydrogens are very, very small. So maybe we'll just represent, one hydrogen here, and it has to be the same size, right? Because a hydrogen is a hydrogen. But look at the bond length between a hydrogen and the nitrogen, right, from center to center, and a hydrogen to the center of the sulfur. Since the bonds in H2S are longer, mainly because sulfur is a bigger atom, the attraction isn't as much, right? If you aren't close together, chances are you're able to drift apart from each other. Think of childhood friends, or if you have a best friend, you're super close, you're really tight, right? You have a close bond. But if you're just acquaintances and you're not best friends and you have a farther away bond, not as close, you'll drift apart. And that's what hydrogens do with acids. The hydrogens want to leave, and it's easier for a hydrogen to leave if it's not as close. Since the hydrogens are bound together more closely to the nitrogen, it's really, really hard for it to leave. And that's why here. So longer bonds, sulfur also is larger. So sulfur has a increased radius. So all of these ideas play into why as to why H2S is the stronger acid. So hopefully that makes sense. Also, one last thing, NH3, whenever you see NH3, we don't even think acidic, we think basic. NH3 is ammonia. So it generally will act more as a base than an acid to begin with. So there's another reason why. But I hope this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel if you want to help us out. Thank you so much for that, and I look forward to helping you in later lessons. Bye-bye.